Wi-Fi Sheep is proud to partner with PCBWay.com. New registered members get their first 10 PCBs free, plus a $5 welcome voucher. Visit PCBWay.com and click on the New Here tab. Then enter some basic details to register. Visit PCBWay.com today. Hello and welcome back to another Wi-Fi Sheep tech video with me, Tom. Now, I've just got back from the Milton Keynes Raspberry Pi Jam. This was held at the National Computing Museum at Bletchley Park in Milton Keynes. If you missed it, it was on the 20th of July 2019, and I had an absolutely fantastic time. It was absolutely packed. We had over 100 visitors or something, and really great fun, great venue. If you missed it, you really did miss out. I believe from memory that they're having another event this October. Date will be on your screen right now, and a link to that will be in the description. I got to be honest with you, I don't think I'm going to be available for that one. If you follow me on Twitter, that'll be at Wi-Fi Sheep. That's at Wi-Fi Sheep. I'll keep you up to date on where I'm going to be exhibition-wise. Speaking of exhibition-wise, I am almost nearly confirmed for this year's Retro Computer Festival. That's being held at Cambridge at the Centre for Computing History, and that'll be on the 7th and 8th of September 2019. Again, details, you can go to their website. That's www.computinghistory.org.uk. Link to that again is in the description. Now, ahead of the Milton Keynes Pi Jam, I set up this BBC Master 128 with a view of taking it to the show to show off the Raspberry Pi CoPro. Now, we've dealt with the Raspberry Pi CoPros, or the PiTube Directs as they're known, before. And last time we actually installed a A+ board into this particular computer. And I said that once we'd done the show, I would go over in more detail some of the software and features and things you can actually do with an enhanced 8-bit micro. However, before we get started, I need to make a couple of modifications to the machine. One of them in particular is to help you be able to see what's going on screen, and that's to link a direct video output. This was something I was criticised with last time, where I just pointed the camera at the screen, but people actually wanted to see a video out. So to achieve this, we'll first need to get back inside the computer. Now I'm going to remove the Pi and the PCB daughter boards, as what I'm looking for, I think, is underneath them all. Okay, what I was looking for was an unpopulated solder pad on the main motherboard labelled as LK11 or Link 11. The plan being, if you soldered the two sides of the pad together, it would give a colour composite out. But all I found labelled was LK14. And as it turns out, this is an issue 1 Master 128 board, and it doesn't even have a Link 11. Instead, relying on a bridging capacitor, which I don't have the parts for. So, plan B. First we need to cut the mono composite video wire off the back of the BNC connector. Then, as a quick fix, I'll just attach one end of the crocodile lead onto the central terminal. Okay, around the other side of the board is an exposed metal wire leading into the RF modulator. Believe it or not, this wire is a colour composite signal, so I'll just attach the other end of the crocodile clip to it. Right, so it's really cheap and nasty, but hopefully this mod will jump colour video to the BNC jack. Speaking of which, BBC Micros had a less than common BNC type connector for composite video. However, you can get a jack to convert the BNC to normal RCA phono, which allows us to plug in a standard type phono lead. Okay, first things first, let's see if we can get any kind of video signal when the machine is powered back up. And yep, that's looking promising, but is it a colour signal? With BBC Basic, you can type the word colour, that's the British spelling with a U, and a number to change the text colour. And yeah, I'd say that's working. So, just need to put the top case back on the computer. Right, so that's been done, so hopefully you'll now get a good video feed and you'll be able to see what's actually happening on the computer, or what the computer's outputting in full colour. Okay then, so let's start up. So we turn the computer on. and you can see it loads straight to its stock command prompt for a BBC Master, which is Acorn MOS or Master Operating System. The floppy driver, which is by default the Acorn 1770 DFS or Disk Filing System, and then it loads in the basic interpreter, and that's where it's waiting for. Now we can check if the CoPro is working correctly by doing a soft reset. So we just hit break, and you'll now see that the command prompt has changed, and it has indeed loaded in the Acorn Tube interface, and by default the PiTube direct board is set to load a second 6502 processor. So we'll start by looking at software for the 6502 CoPro, and as I mentioned this, I think last time we did the CoPro video, which was a few years ago now, the only real game that was ever released was Elite. I have my Elite image, so making sure we're in the correct disk image, we can go hold down Shift, break, and let go. This is the disk image from Ian Bell's website. He's released it free and basically has all the versions, as you can see here. So the Model B with sideways RAM, the original Master 128 colour version, but we want the 6502 second processor Elite. So it's a lot more colourful, and it does the whole Star Wars intro thing. Runs a lot faster as well. Again, because the CoPros were so expensive and mainly used for scientific, academic or business software, there wasn't really any games ever written for them. So, well, originally anyway. So the Elite was probably one of the only ones I can think of. And there we go. So we've loaded up. So you notice all the fonts have all changed. The natural colours, it's running a lot smoother. So we can hit F0, yes. Function 0, and we're in. That shoots. I can never remember the keys on this. That's up, down, left, right. There we go. There's still a little bit of slowdown when you get around the planets. Find where's the space station gone? Should be here somewhere. There we go. And there's also a lot more AI traffic of a craft. So I'm just gonna, I always, for demonstration purposes, I'll just get into a fight almost immediately. Now it's on, and I last about 5 seconds, but it's fun. So Elite really gives you that ability to do full 3D sort of dogfighting, and it was just a revolution at the time. No one had ever seen anything like this, especially on the 8-bit platform such as the BBC Micro. Oh well. Lasted better than I thought I would, but there you go. So that's Elite, and that's probably one of the best demonstrations of the 6502 second processor. So we'll end that. We'll just hit break, and the computer will kind of do a soft reset. So we switch disk over. Okay, so the advantage we have with a PiTube Direct CoPro is we're not limited to just one coprocessor. We can talk to the Raspberry Pi inside the computer through the BBC Micro. So if I call asterisk or star, I keep saying asterisk and I got told off for that, so it's star command FX, and now we say 151230, and now we can actually set the processors to change on the fly to what we want. So at the moment it's the second 6502. For my next demonstration I'm going to switch it over to an Intel, that's x86 architecture. So I'm going to select 8, hit return. Now if I soft reset, you'll see that we've now changed to an 8286, so 286 processor, and a lot more RAM has now come over. So we've nearly got a megabyte of RAM in the system. That's 896k. Again, I'm going to need to load off disks. So now what we can do is we can actually start loading some IBM PC compatible software. So I'm going to load DR-DOS. This was a special version of DR-DOS, not to be confused with MS-DOS, although they were both very similar. And this was done for the what was the Master 512 system, which this has now virtually become thanks to Raspberry Pi CoPro. So we need to switch the disk controller, because at the moment it says Acorn 1770 DFS. These disks use the ADFS, which is a slightly later Acorn filer system. So if I go Control A and then hit break, you'll notice the filer system changes and the floppy disk is now going to kick into life. And it's going to load Digital Research DOS Plus, or DR-DOS, as it's also known. And we're now basically entering a almost fully IBM PC compatible environment. Okay, and now we have an A prompt. So we're now switched over from Acorn commands to DOS commands. So if I want to get a directory of the disk, it is dir. And there's actually a full directory of the disk. Now what we can do is actually load up a full graphical user interface on our 8-bit BBC Micro. I'm going to switch the disks over. We can now load a Windows alternative called GEM. To do that, I'm just going to type GEM. Then when I switch the disks over, so we're now loading up a second floppy. Admittedly, this one does take a moment to load off floppy disk. And there we go. Now GEM had a very early Macintosh Apple desktop feel to it, so much so that they were actually sued by Apple and had to change the operating system. So this is GEM 2, and instead of having a full desktop with icons like a Mac, GEM 2 had to have these two fixed windows here and here. Other than that, it's very, very similar. For those of you that ever used the Atari ST line, you're probably looking at this OS and thinking that looks strangely familiar. GEM was actually used in what was Atari, or TOS, which is the operating system on the Atari ST system. The software isn't actually directly compatible because we're running as an Intel x86. The Atari ST ran a Motorola, I forget what chip it was, 68,000, something like that. Anyway, 16-bit chip. So software wasn't compatible, but we are actually compatible with a lot of early PC DOS software. Anyway, so we've got menus. This is also where I need my mouse. I've got my trackball mouse. It's very free-flowing, very fast. We can open up an application. So we've got paint.app. That's actually on the same disk as the main desktop filer. And we've now actually got a full Paint graphics program, which is very similar to sort of Microsoft Paint you used to get with Windows. There we go. Now, this is actually a colour software, colour application, colour operating system. The problem is the BBC Micro's video chip, the ULA chip, although I've replaced it, so I have an advanced one, it can't really do anything to help me here. So if we want to run at the highest resolution possible, which is the 80 column mode, or mode 0 in BBC Micro speak, then unfortunately it can only display two colours, and the best two colours to use is obviously black and white. If you brought your resolution down, you could add a colour to the system, and then you could have four colours, but all the text and fonts I found started bunching together and it actually looked a mess. And to be honest with you, the colours you got were what? Red and white, black and white. It wasn't really worth it. So I set this up to run in the higher resolution and we just sacrificed all the colour. By the way, I don't know what I'm doing, but I've just showed it. You've got the ability. I don't know if that can come. No. Okay. But it's a fully fledged operating system, and you can actually should be able to resize windows from memory. Yes, there we go. Wrong mouse button. And we can actually move around. So what I have done in the past, I can't do it today because I haven't got a double disk drive set up, but if I had another disk with some files on it, I could actually open and have multiple paint files open within the workspace. And you know, that's quite impressive. No. Okay, we've just come back to the main DOS prompt again, so we've just exited it out of Gem. One of the things we can do, remember this is supposedly a full IBM PC clone compatible environment, so we can run a number of PC applications and games. So let's just have a look at actually how we go about creating and loading up a new disk image into the system. Okay, first off, I headed over to this forum post on Stardot, link in the description, which gave a list of DOS software compatible with the master. I think I'll try the helicopter simulator. Also, if you're looking for disk images or help with the master DOS system, then head over to cowsarennotpurple.co.uk. Again, link in the description. This is where I got my master DOS and Gem disk images. Okay, so next we'll head over to Windows XP as we need to format a 720K double density floppy disk. From the run box, type CMD followed by enter. In the DOS prompt that appears, type format space A colon space /T colon 80 space /N colon 9 followed by the enter key. DOS will ask for a floppy. I'm using this used disk, and we'll wait a few moments for the disk to format. Okay, now from my computer on Windows, we should be able to open the A drive. Now, inserting a USB drive with the unzipped programs we downloaded on it, open a drive on Windows and find the files. Then drag and drop or copy and paste over to the blank A drive. Again, copying will take a few moments. Okay, so I've got that disk I made on the PC actually next to me. So this was formatted on Windows using the zip files we downloaded from Stardot. So new disk in, let's just hit dir again. And those are actually the directories. So we can actually navigate as you would on DOS. What I'm going to do though, now this is really cool, is I'm going to put my disk 2 back in. I'm going to go back into Gem. Oops. Okay, a few moments later we're back. So I'm going to swap the disks over. You can swap the disk over when the desktop is actually loaded into RAM. Now it does denote 2 disk drives. It's really meant to work with 2 5¼ inch drives. I've got one 3½ inch, so if you hit try and open B, there's no drive in the system, it kind of crashes unfortunately. So but I hit A, bear in mind I've just put that new disk we wrote back in. There are the folders now denoted as folders, and we can actually double click and navigate visually. So if I click on the helicopter sim, so this is the helicopter sim we downloaded. This is an original game from Sierra, and there's the .exe, so you'll recognise that any PC user knows what .exe is, an executable. So it recognises it as an application, and we can just double click. It'll then ask me what I want to do, which is we're just going to open the application. Bear in mind this is a pure DOS application, not a Gem application. So we exit out the graphical user interface and we start loading up HeliSim game. So again, working off this, got to give it a minute. And there we go. Now we are Sierra Online 1987. You'll also notice that it's actually not only supports the graphics mode, it supports the full CGA PC graphics mode, including the god awful colour palette. So we can actually start this. I have been sort of trying to practice I remind you, what you're now watching is running on an 8-bit BBC Micro, not an IBM PC compatible. We will probably start spinning around in circles. So it's crude, but it's also rather impressive that we've actually got a full 3D world. And we've actually got colours and we've got shading. I think before we all get dizzy, what I'll do is I'm going to hit escape and we'll navigate through to demo mode. And it'll now run it on an autopilot, and we can just look around from the different viewpoints. So there's the sort of overhead map view. That's from inside, that's externally. And there's the view tracking from the ground. And while that's playing, we can hit escape and we can navigate using the cursor keys all the menus. Now I was hoping that we would have got full mouse support happening, but it's not happening unfortunately, so we can only navigate through using the cursor keys. Also, though it says sound, we're not getting any sound through the system, so clearly the sound, PC sound, isn't compatible with the BBC Micro. But saying that, it's actually really impressive how it's running so well, considering this is a piece of 16-bit PC software I've written for the IBM PC on a 286 processor. Now when we're done, we'll hit quit. And I remind you, we entered this not from the command prompt, but from Gem. So Gem actually comes back up. It does need its desktop boot disk, which was disk 2, back in the system. And we'll say OK. And it's actually remembered where it came from. It's going to put us back on the desktop again. So yeah, I actually think that's really cool, and I'm looking forward to playing with this a bit more. And it's just nice to have a computer capable of doing this, especially an 8-bit BBC Micro. It's really impressive. So there we are, the Gem Desktop 2, March 24th, 1986. Let's talk a little bit now about modern features. We touched on this last time, but there wasn't really any modern features to show you. As well as a long line of co-processors this thing can emulate, including things like Z80s. We talked about Second 6502, we've done the Intel. It can also do ARM processors, including the ARM 1 and 2, or, what I'm about to show you now, the native modern ARM of the Raspberry Pi. So if I now talk back to the Raspberry Pi, so that's FX 151 230, and if I now ask for 15 on the system, you'll now notice it says native ARM coprocessor. It's logged in at 700 megahertz. Normally it'll do 1000. Bearing in mind this is a Raspberry Pi A+ board, so it's running at the native 700 megahertz. That's quite cool. Let's just do a control break. There we are. And it's now loaded up the ARM prompt and it's waiting for instructions. It has put BASIC back into the system, but BASIC on ROM is designed for 6502 architecture, so it's not going to run properly on an ARM chip. I do have here another disk which I showed in the last demonstration, which was a 32-bit version of BASIC. Bearing in mind we're now running in 32-bit mode, so let's just catalog that. There we go. And if I now type BAS 135 in, you can hear the disk whirring away again. It's now going to load in a 32-bit version of BBC BASIC. This is BASIC 5. There we are, BASIC 5 is loaded in. And we can now actually look at some programs. So I did the circular program from last time. So we load CIR and we can list. Now if you remember, when I try and run this, it actually fails at line 30. We say list 30, and originally I thought, well, that's a valid command. It's circle command. It's something unique to BASIC 5, And I thought, well, why isn't it understanding it? And a few people commented on that and told me it was about the tokening system of how BASIC works. So this program was written in BASIC 2, which doesn't understand the circle command, so it didn't assign a token to it. We've saved it as BASIC 2, we've loaded it as BASIC 2, and of course it still doesn't have the tokens correctly assigned to it. So BASIC 5 doesn't actually recognise that command, hence it causes the problems. The minute I copy, using the unique BBC Micro copier system, put the line back in, it now operates perfectly fine, and there we are drawing circles on the system. I can escape that. Mode 0 again, list the program again. If we change to 10, same mode 2, lower resolution mode, but we now get full colours in the system, and then we have colour circles drawing on a 32-bit version of BASIC. So this would work with our RISC-OS build for the Raspberry Pi. BASIC is included. You could do this program in much higher resolution and much faster than this, but it just gives you an idea. Now, at that point, it was pretty much the end of the demonstration because there wasn't any other software that was using the code processor. However, since then, things have changed. And my good friend and friend of the channel, Rob Coleman, that's the designer of the Video NULA graphics card, actually has produced some new emulator software that combines his Video NULA card and the PiTube Direct Code processor. So I'm going to put this disk in, keeping us in native ARM mode, and we'll just catalog that drive. And this, believe it or not, is a ZX Spectrum emulator for the BBC Micro. However, we do have to load a component into sideways RAM, which is why on the BBC Master, which has sideways RAM as standard, you've got to clear all your EPROMs out other than the operating system in order to free up the space that we can then allocate that to basically soft load a ROM. Okay, so to do this, we'll go SR load. We need to page the ROM, which is, well, first of all, we need the ROM file. So we'll say SP ROM, page 8000, sorry, in memory, and we'll put it into allocation 4. Control break. Just check ROMs. You can see I actually accidentally loaded one into ROM 5, but that's unplugged. But we are actually in ROM 4, and that'll be fine. So now if we just catalog the disk again, now we should be able to call ZX spec. And as you can see, it has actually loaded as a ZX Spectrum emulator. Unfortunately, I can't get any software to load at the moment. I haven't got this working properly, mainly because of the filing system issues I have, and I need better equipment or better filers, which is unfortunate, but I thought it was worth showing you because I think this is actually really cool. When you do actually get this working, it will be really cool. Basically, how this is working is this is the off-the-shelf open source Fuse emulator compiled for native ARM processor. It's not running as a true Z80. The emulator is then basically emulating a Z80. The Raspberry Pi CoPro is doing all the processing work, and it's just sending the video data back to the BBC Micro to display whilst listening for keyboard inputs. So we can actually try and type program in BASIC. And without a full ZX Spectrum in front of me, this is actually going to be a bit difficult because I can't remember the key commands for. That's not right. 2 no equals yes, 2 equals, what am I doing? No. I am not a ZX Spectrum user, so that ain't gonna work. There you are, 10. That's the best I can do. But you could actually do full programming in this mode. It's actually really, really cool, and I hope I can at some point get some program proper ZX Spectrum software working on the BBC Micro. One recent development, also from Rob Coleman, is a port of the 1993 DOS build of Doom. Yes, that's right. With the combined Video emula and PiTube Direct working together, an 8-bit BBC Micro can run Doom. And although a little slow, it's not too bad. Well, it can't be any worse than the Super NES version. To see this video in full, please visit Rob Coleman's channel. And a huge thank you to Rob for letting me borrow this footage. Links are in the description. So there we go. I really hope you've enjoyed that brief tour of CodePro environments for the BBC Micro, and also you can see for yourself how the technology has kind of improved as new features, new products, and basically new people come into the scene to develop code for the system. So it's a really exciting time to be doing this. Now I know what some of you will be saying. The Raspberry Pi on its own could emulate and run virtually all the programs and software I've shown you in one form or another. And yeah, to be fair, you are completely right. That is true. However, I don't think it's as fun to kind of just have a Raspberry Pi that just runs it. Okay, yes, you can do it, but it kind of misses something. At least with this, we're using original 8-bit hardware, we're adding to it. So when I go out to shows and exhibitions and I can show people, there's a bit of a sort of a nostalgic thrill factor in seeing original 8-bit hardware doing all this amazing stuff, be it with Raspberry Pi assistance, rather than just having a Pi board on its own. It kind of, I mean, you might disagree with me on that, but that's kind of where I come from. But if you're interested in just wanting to sample the software, then yes, all the DOS stuff, all the ZX Spectrum stuff, the Acorn, BBC Micro, and even the 32-bit stuff, you can all do on the Raspberry Pi. In fact, do check out our own operating system, that Wi-Fi sheet build of RISC OS. We do actually have the emulators for BBC Micro, DOSBox for PC, so all the x86 things you saw, and also we have the ZX Spectrum Fuse emulator on there. So if you just want to run the software that I've shown you, you can go and download it from various sources. That's probably the quicker and easier way to do it. Anyway, I really hope you've enjoyed seeing what we've done here today, and maybe it's inspired you to have a go at setting up your own micro. We'll be doing lots more projects like this in the near future. So as ever, don't forget to like and subscribe, and I'll see you real soon right here on the channel. Until next time, bye for now.